Hi dear students. Let's see this question that came in JEE Advanced Paper 2 Physics in the year 2020. This was a multiple choice question based on the concept of circular motion and work by energy. The question was simple per se, but due to one of the options, I believe there was a slight ambiguity. IT had given option A and D to be right, but let us see why, in my opinion, option D should not be right. First, let us look over here why or what is happening over here. A particle has been launched at an initial velocity of v0 from the bottom on an inclined plane of inclination 30 degrees. The particle will make a circular motion and then it will come back. The top point, which is y, is at a height of h from the bottom. We have to ignore any energy loss. Also, at the top point, the centripetal acceleration is going to come from the weight of the particle only. So using these conditions, we have to comment upon the V naught, like we have to check the options. Now, as I told you, the question is not very difficult. Since the energy loss is negligible, so we can just conserve the energy. If the initial speed is V naught and let's say the speed here is V, so initial kinetic energy, which is half mv naught square, that will be equals to potential energy at the top, which is mgh, plus half mv square. So from here we can see that v naught square minus 2gh will be is equals to v square, right? Now if we divide this by, or we can simply write, this is equation 1, we can simply say that force equation at the top point. So centripetal acceleration will be mv square by r, r is the radius of curvature, that should be equals to mg sine 30, because only gravity along this direction is going to provide the centripetal force. So m will cancel out, and from here we can say that v square will become rg by 2. So if you put the value of v square over here, we get this, which was option A, and hence option B was wrong. Now, if you read option C and D, the centripetal force required at point X and Z is 0, or the centripetal force required at the point X and Z is maximum. IIT had given option D as correct, using the logic that here if the speed is some v dash, then here also speed will be v dash, and over this whole circle the speed will be like v dash, and v dash will be maximum on this circle. Like if we compare the speeds at the different part of this semicircle, then the speed will be maximum at x and z. So v square by r is maximum, and hence centripetal force will be maximum. But let us see what might be a flaw in this thinking. Here the keyword is required. Now at point X, the circular motion is about to happen. If I do not provide the centripetal force at point X, then particle is not going to turn. The particle is, its velocity vector is not going to change. Think carefully. Its velocity vector needs change. So here the centripetal force is required. But what happens at point Z? Here the circular motion has already happened. The velocity vector does not need to change. It can continue in a circle, in a straight line. So if it can continue in a straight line, here there is no requirement of any force. Hence at Z, there is no requirement of any centripetal force. It can simply continue along this straight line. Even if we assume gravity free space, then it can continue at constant velocity, right? So the idea is that there was no requirement of centripetal force, and this is the word that created sort of ambiguity. If I was a student, then I would not have marked option D as correct, because according to me, option D should not be correct. One more thing, there were few students who had this doubt that since there is no friction, hence since the energy loss is negligible, so we have to ignore friction. So since there is no friction, so what is causing the centripetal force at point X? So that can be explained. We can assume some sort of groove in this part. That means we can assume some gadha, some groove in this part, which is guiding the particle to move in a circle. At point Y, we can assume the groove has been leveled. That means this groove has again become, at these, like it has been leveled with the inclined plane. So in this part, groove can be created, which is smooth. So centripetal force can be provided by different means, which is not exactly shown in the diagram. But as I said, at point Z, there was no requirement of centripetal force. Now, this might also create some confusion that then what is that mv dash square by r, which is acting over Z. Let us deep down, let us think carefully in this scenario. If so, this is the inclined plane, this is x, this is point Z. See, if particle continues on a straight line, now this point Z can be thought of as the end point of the circle or the starting point of the line. For the line, if you think, then radius of curvature is infinity. So if we try to compute the centripetal force from the perspective of line, then centripetal force will become zero. And hence there is no requirement of centripetal force for the particle to move on this line, because r is infinity for this line. Since the particle is about to go on this line, hence I can say that there was no requirement of centripetal force. No matter what is the speed, the radius of curvature on this line is infinite. Therefore, I can say that the requirement of centripetal force was not there. This is my take. I hope you would have enjoyed it. Thank you.